now that we've seen how to solve trig equations in Regian mode, we could actually do some real-world applications. The most famous application, and it's a little bit contrived, but it's sometimes called the Ferris wheel problem. So if you've ever been to a carnival, Ferris wheel is this circle thing that goes around, usually, I don't know which direction it goes around, probably clockwise or counterclockwise, and you get on and it goes around and around in circles. Now, because it's a circle, the position, your position on the Ferris wheel is going to follow some kind of a sine curve. It's going to, let's say I start here at my lowest point. It's going to go, or cosine curve is maybe more accurate. So as you go around, your height goes up and back down, and up and back down, and up and back down, producing, if I make time go this way, and height as the y-axis produces cosine curve. These are generally just called sinusoidal. Sinusoidal curve is anything that's like sine curve, cosine curve, shifted sine curve, however. So we're going to need some details about this Ferris wheel. They tell us that you get to the top of the Ferris wheel after 3 seconds. So on our graph, we have this 3 is sort of the high point. Now, the diameter of the Ferris wheel is 40, and when you get on, you're actually 3 feet above the ground. So our high point, we're up here at 43. Now we're also told that it takes 10 seconds to make a complete, 8 seconds to make a complete revolution. So that means here's 3, 4, 5, 6, 7, 8, 9, 10, 11. Our next time we're at the top is going to be 11:43. And halfway between those is 4 seconds, which is going to be 7, and our low point is going to be at 3. So 1, 2, 3, 4, 5, 6, 7. And here we've got our sinusoidal. And at this point we create an equation. Y equals, now it's a cosine curve, but it's a cosine curve. The middle line would be here at 23. That's the average of 46 and 3. So I'd have plus 23 over here. The amplitude is 20, so it's 20 cosine. The starting point is at 3, so it's x minus 3. It's 3 to the right. And because the period is 8, the b value is 2 pi over 8, which is pi over 4. And this is the equation that tells us the height. Y is the height, and x is the time at any time. Now they could ask you questions like, what happens when x equals 5? Well, you just plug 5 in and work out the value of y. But the more complicated question is to figure out, name 2 times that the height is 38 feet. So there's one time between 3 and 7, another time between 7 and 11. That we can calculate like we did in the last lesson. By subtracting 23 from both sides. Dividing both sides by 20. 15 over 20, I can reduce that, divide both by 5, so I'll just write 0.75 equals cosine. the reference angle is going to be cosine inverse of 0.75. Even if this was negative 0.75, that would be my reference angle. And I'm in radian mode, so it's 0.7227 radians. But cosine is positive in quadrants 1 and 4. So my things that I'm going to set equal to are going to be 0.7227. But also, in quadrant 4, it's 2 pi minus 0.7, 2 pi minus 0.7227. Those things are going to be set equal to this expression, pi over 4 x minus 3. Now you multiply both sides by 4 over pi, and then add 3. I'm just going to write pi over 4 times 0.7227 plus 3 is equal to x. That's one of the answers. That ends up being about 3.9. And the other answer, if I multiply pi over 4 by both sides, I'm going to write pi over 4 parentheses 2 pi minus 0.7227. Pi over... I have to multiply, sorry, I made a little mistake here. This is 4 over pi. And this is also... I'm getting rid of the pi over 4 by multiplying both sides by the reciprocal plus 3 equals x. And when you pop that into the calculator, you get x is equal to 10.1. There are other scenarios that we can create, but basically the way I see it is that your steps are, you take the word problem, and based on it, you draw a diagram, and then based on the diagram, you come up with the equation. The equation is usually cosine curve, and then you solve it like we did in the last lesson. Okay, that's good for now.